So this is a 2003 gate question. So let's look at the question. A bullet of mass m travel at a very high velocity v and get embedded inside a block of mass m initially at rest on a rough horizontal floor. The block with bullet is seen to move at a distance s along the floor. Assuming mu to be the coefficient of kinetic friction between the block and floor and g be the acceleration due to gravity, what is the velocity v of the bullet? Okay, we have to find the velocity v of the bullet. The bullet is penetrating into a block, and after collision the bullet is moving along with the block. We have to find the velocity v of the bullet, final velocity with which it hit the block. So looking at the solution part, we have just assume u be the initial velocity of that combined mass. Okay, we are considering after collision case. So we know after collision both the bullet and block will be the same, a combined part, right? So let u be the initial velocity of that combined mass, capital M plus small m. Capital M be the block mass and small m be the bullet mass. Okay, let it be the same part after collision, and let u be that initial velocity, I mean that combined movement after when the bullet penetrate the block, it start moving, right? So from that moment, that assume that initial velocity be u. Okay, so we know by principle conservation of linear momentum before and after. So just apply that. Before collision there was only that single mass moving. The only thing that has momentum was bullet. It was having a velocity small v and having mass small m. So the momentum before collision, the block was initially at rest. Only thing which has velocity, I mean the one which has momentum, was only bullet, right? So mv is equal to, after collision the both will be same part, so the mass will be combined but the velocity after collision will be same. So I will assume it's already the same part, so capital M plus m into that velocity after I mean just after it will be moving with some initial velocity, right? Just after collision. So let it be u. Okay, so mv is equal to capital M plus small m into u. So I will get that the combined initial velocity u would be m by capital M plus m into v. Okay, get that will be equation 1. Then applying the velocity acceleration equation from the equation of motion, that is v square minus u square is equal to 2as. Okay, take the basic equation, but here they have mentioned the kinetic friction mu to be the kinetic friction between the block and the floor. So I cannot simply write as acceleration. That's the only thing you have to, most of them can do up to this part, but the thing you have to keep in mind, if there is mentioned kinetic friction between the block and floor, so you have to, the net deceleration will be mu into g. Here they already mentioned it is take acceleration due to gravity, so then there won't be any other acceleration or a, so take acceleration as g. Okay, acceleration due to gravity. So it was actually v square minus u square 2as, but we know it is a deceleration because it will be decelerating after that collision, so it will be minus g. That's how that minus came, and finally it will be in rest, so v will be 0. That's why 0 minus, so 0 minus u square equal to, it was supposed to be minus 2gs, right? Acceleration is minus g. Due to deceleration I am giving the negative sign. It was minus 2gs, but there's a mu term come because there is the friction and deceleration of the combined mass will be mu g, not simply g. If there is a kind of friction mentioned, we have to remember, we have to multiply like mu g. Okay, that's only main point you have to remember this question. So it will be minus 2 mu gs. Okay, s be that displacement after collision. So that's solving that, you get u as root of 2 mu gs, right? So we have two equation of same LHS u. So simply equating, you can find the velocity v. Okay, you can find that velocity v of that bullet. What is the velocity v of the bullet? As m plus m whole divided by m. Okay, so whole divided by m into root of 2 mu gs. That's the final velocity of that bullet.